All right, so testing in the onion. This will be a shorter talk because we don't have enough testing. The purposes of testing, of course, is to discover any problems as early as possible and make it less scary to change the code. Because once it's scary to change the code, that means that the development slows down and it makes the code worse over time. Our tests run on all the pull requests on the build machines. We always run checks to make sure the code compiles and some basic tests on Windows. But the more sort of extensive platform tests are only run if you request it. So you should enable them if you suspect that your code will cause problems on machines if you're touching systems that are a bit more sensitive in that way. It would be nice if we could always run them, but they're pretty expensive to run and our builds are kind of slow on the build machines it is already. So for now, that's the solution we have. So we have two different types of tests in the onion. We have the unit test, which tests sort of an isolated piece of functionality and asserts that it behaves as expected. The unit tests run really fast. Running all the unit tests for the entire code base takes a couple of seconds or so. So it's really simple, something you can easily integrate into your workflow. The integration tests are used to test that everything works together, sort of when you put all the different systems together, that everything still works. So the integration tests are used for anything that needs to like load project data from disk, do something else, anything with a real complicated setup. They run pretty slow. Usually running the integration test on a platform takes several minutes or 10 minutes or something. And if you're doing it for the first time on your computer, you'll spend a lot of time just syncing the data for the tests, which makes it even slower. I would say, like, comparing these two kinds of tests, that the unit tests are really awesome, super helpful, pretty easy to write. If you write the unit tests as you write the system, I think the effort, you almost always gain back the effort because it's easier to write the system. Just writing out the tests make you think a little bit about the API and so on. And the time you save in finding bugs easily compensates for the time it takes to write the test, which isn't really that long for just unit tests. Just do some stuff and check that you get the expected result. Integration tests, it seems, my experience is nobody can be bothered to write them. We wrote some, when I created the integration test system, I wrote some initial integration tests, and those are pretty much all that's run. I know Dan added some flow tests, and there have been some physics tests added and so on, but we don't have nearly enough integration tests to really detect bugs. And I'm not sure exactly why it is. Is it because the system is bad? It is a bit bad. You have to write the tests in Ruby, which is kind of complicated, and it's not easy to set up a really simple test. Is it because it's really a pain in the ass to run these tests because they take multiple minutes, and running them on the server machines, historically we've had like a lot of false positives, and or is it just because it's a lot of work? It's a lot of work to create a new scene and spawn some stuff in that scene and so on. I'm not exactly sure what the issue is. I would like to, I think, to get better integration. I think to get better testing in general, we need to do more unit tests because those are universally awesome. Put them in everywhere. But I also think in order to be better at testing in general, we need to figure this out. What's the problem with our integration tests? Why aren't people writing them? And how can
I think there's several problems. One good example is that when we added the light baking shader, that added like 2 minutes to the compile of the core directory per regression test. So there's the fact that if we're not careful, we introduce changes that make things much slower. There's the fact that definitely you mentioned before that it was flaky before. At least on Windows now, it's really solid. I actually had someone the other day tell me, "Oh, my PR is failing because of the tests," and then they realized it was actually their code that didn't work. So that's improved a lot, but we need to keep improving. And
I think the time issue is a tricky one, because currently they take, like, as I said, 10 minutes or something to run, but currently we don't have any integration tests. I mean, we have very few integration tests. Once we extend this system, it will take longer to run the tests, which also makes them less useful.
I would actually like the core folder to be somehow pre-compiled just once, and then that would speed things up a lot, either with the cache or some other solution.
But if you look at other big projects like Unity, I think their tests take like days to run if they run all the tests. So
we can also split it into tests on every PR, but also nightly tests as well. I
think. Something needs to be done there anyway to get a better system. Unit tests. The unit test system, the tests for the unit system are just ordinary functions, ordinary C functions, called with an iTestRunner class as argument. And this is just an abstract interface to sort of the test runner. You can use it to detect whether a certain test should run. So you can specify from the command line, when you run the unit test, you can specify that you only want to run unit tests for a specific file, for instance. So then you can test here if the tests in this file should run. Usually that's not really needed, since the tests run so fast, you can just run all of them, but it's there. You can also check the test time. There's also, normally we assume that we will be able to run all the tests in seconds, but if you want to make a complicated unit test, you can do that, but then you should make an if statement where you check the test time if it's set to, and only run that complicated test if the test time is set to minutes or hours. And then there's this can use function too. Normally when you run the tests, it doesn't touch the disk and it doesn't touch the network interface, because those things tend to be slow, but you can enable that with flags. So if you have a test that needs to use the disk or needs to use the network, you can use this to test if testing for those systems has been enabled. And then this assert function here, that's the main assert function. It's usually called through this macro. So it will test some assert and will have a message, will record the file and the line where the assert was made. So then we have a hierarchy of these test functions. So we have a master test function somewhere that calls into test functions for each system. So this is, for example, our collection system. It has a single method that's called by the master test function, and then in turn calls separate test functions for testing different parts of this system. And it's pretty, writing tests like this is pretty simple. This is testing the array, test that it's empty in the beginning, pushes back a 1, test it has 1 element, and so on. So these things can be added quite simply. We compile the tests as part of the regular engine. We don't have a special compile flag for compiling with unit tests. We always compile with the unit tests, and you run them with a special command line parameters to run the unit tests, and you can specify these things if you want to test for hours or minutes, if you want to test a disk or the network and so on. And you get a report at the end of your run that says if all the tests passed or which tests failed, and then you can go on to debug them. The regression test system or integration test system, as I said before, that's a Ruby script. And what it does to run a test is typically it starts by synchronizing a project file from Git. So it gets all the data belonging to a particular Stingray project. Then it compiles that data and runs it on a specific platform. It supports all the platforms that we support. Then it sends Lua commands to that running game, sort of get the game up and running or get the project up and running, and then it can talk to it with Lua commands over the console connection, and also check the results of those Lua commands. So starts it up, sends some Lua commands, make sure it doesn't crash, and make sure that the Lua commands return the things that you expect. So a test for this might look something like this. This tests the character template, which is one of the template projects in the Onion. It has a setup phase where it will install this project from the Git repository. So these are the things that take time if you haven't compiled the test before, just installing this and then compiling the data. So this is the actual test function. It compiles the project, it runs it, and as it runs it, it creates a session with the console server for talking to this running. And with this session, it sends some command. It sends 3+2 as a Lua command and makes sure that the Onion returns 5. It sends a request for the level name and makes sure it matches what it expects. It switches level, make sure that the level was actually switched, and then print some statistics. So, and these are typically, as you can see, there's not that much that is actually tested here. But basically, it's pretty much a test that we're not crashing. We're not really testing any systems. We're just testing that we're not crashing. So yeah, a lot more work to do to make more extensive integration tests. Another thing to note is that we don't have any rendering tests right now. We don't have any automatic image comparison or tests of rendering results in this regression test system. But I know there is some work being done on that. I'm not sure exactly how far it's progressed since I'm not into the rendering side that much. Yeah, but that was basically all I had about the test system. Any questions about that? All right, thank you. Talk again tomorrow. Cheers.